Hello everyone, Christopher here with McWane Science Center, and welcome to SciSparks. Today's episode starts with a mystery that might make your head spin. Think you can solve it? Stick around and find out. Here we are in McWane Science Center's adventure halls where we find this curious little nugget. Inside this case is a hefty metal wheel, but aside from making our case extra heavy, it doesn't seem to do much at all. That is, until we get it spinning. Right now, a hidden electromagnet is accelerating our wheel to truly ridiculous speed. Listen, you can hear how fast it's going in there. And now that our wheel is spinning, it may seem at first that nothing's changed, but then, weird. It seems to be defying gravity. So what's really going on? In order to solve the mysterious case of the mysterious case, we'll need to get something else spinning. Something like this. Now, while this plate is still, it's not very stable. It tilts, it wobbles, it falls. But when I get my plate spinning, steady as can be. Watch. No matter how much I tilt the stick below it, its axis of rotation, that invisible line around which it rotates, always stays the same. And that is the conservation of angular momentum. It might sound complicated, but you've seen the conservation of angular momentum before. It's why this wheel is stable while it's spinning, but quickly topples when it slows down. Basically, the faster something spins, the less it wants to tilt or twist. But what happens when we force a spinning object to tilt? When our plate is still, it tilts in whichever direction I push it. But when that plate is spinning, when I push on the side nearest to me, it tilts to the left. Push on the other side, it tilts to the right. Now, this may seem counterintuitive, but when we add together the downward force of my push, plus the sideways speed of our plate at that point, what we get is a direction in between. Our plates tilt, a tilt to the right. Remember our mysterious case? The wheel inside acts just like our spinning plate, but flipped 90 degrees. By flipping our footage 90 degrees, the similarities are obvious. Well, that's it for today. If you enjoyed this video and would like to see more like it, don't forget to subscribe! And if you liked the video, let us know by leaving us a like. Until next time, bye!